All right, here's a couple questions from section 7.6, dealing with quadratic functions. The first one, you need to find vertex information, and the second question, you need to find intercept information. So this first one, they ask you to find the vertex. Two ways to find the vertex. One's completing the square, and the other is using the formula. If I have a choice, I'm probably going to use a formula, especially when I see a number out front of the x squared, because I know I have to factor that out. So I'm probably going to use a formula. So let me show you how to do that. So the formula is you figure out what minus b over 2a is, and that's the x coordinate of the vertex. And then you find the value of the function when you plug in whatever you got on the first section into that, and that'll give you the y coordinate of the vertex. Let's do each one separate. So to get the x coordinate, it's minus b over 2a, and minus b over 2 times a. So b is this one, 5, and a is that one, so 2. So it'd be minus 5 over 4. So for your vertex, oh, it's over here. For your vertex, the x coordinate would be minus 5 over 4. So minus 1 in a little bit, so it's over there on the graph, but I have to figure out a y value first before plotting it. So that's the x coordinate of the vertex. The y coordinate, what you do is you find the value of the function f, this function, when you plug in negative 5/4 in everywhere you see an x. So the function is up here. So it's 2 times x, that's negative 5/4 squared, plus 5 times negative 5/4 minus 2. You could do that on your calculator. I don't have one handy, so I'll just try it the long way. So it'd be 2 times 25 over 16 plus negative 25 over 4 minus 2. So if I multiply, this would be 50 over 16 plus negative 25 over 4 minus 2. Maybe I could simplify that. It'd be 25 over 8. And let's make this an 8, so I have to times the top by 2. And then let's make this one an 8. So it wasn't a 1, so I have to times the top by 8, so it'd be a 16. Okay, so 25 minus 50 is negative 25 minus 16. I think that's negative 41 over 8. I'm pretty sure that you might need to check that on the calculator. But that's the y coordinate of the vertex. So that goes up here where I scribbled things. Negative 41 over 8. And that's just over 5. So negative 1 and a bit and negative 5 and a bit. So right there's the vertex of that parabola. So if I want to know the line of symmetry, it's x equals the x part of the vertex. And since this value is positive, the graph goes up. So it's going to be something like that. I'm not sure where it crosses the x-axis. We'll do that on the next question, show you how to do that. But this is just a ballpark. And so since it opens up like this, there's a lowest number that it can get to, and that lowest number is always a y value. So there's a minimum value of negative 41 over 8. Okay, so here's another question where, again, it's a quadratic, and this time what they want you to do is find the x and y intercepts. Okay, to find the y-intercept, you plug a 0 in for x. So f of 0 is equal to 0 squared minus 6 times 0 plus 1. So there'd be 0 minus 0 plus 1. When you do it out, it'll come out to be 1. So that'll be your y-intercept. And really, if it's written in the standard form, the y-intercept is always that last number. Okay, so y-intercept is 1. And I guess we should, if we plot that, the y-intercept is right there, so at 1. And that point would be a 0 value for x and a 1 value for y. That's probably the proper way to write a y-intercept. Okay, X-intercepts. To get X-intercepts, I plug in a 0 for y, or a 0 for f of x. So my function is f of x is equal to x squared minus 6x plus 1. So I put a 0 here. So I'm not putting a 0 in for x, I'm putting 0 for that whole thing. Equals x squared minus 6x plus 1. And then I'm dying to try and factor this. X, two things that multiply to 1 and add to negative 6. Yeah, not happening. So I can't factor it. So therefore I'd use the quadratic formula. B squared minus 4ac all over 2a. So negative b is a negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a is a 1, times c is a 1, all over 2 times a is a 1. So x equals 6 plus or minus square root, that'll be 36 minus 4 all over 2. Okay, I'm still going. And then 6 plus or minus square root of 32 over 2. And square root of 32 is the same thing as the square root of 16 times the square root of 2 over 2. Still going. So 6 plus or minus square root of 16 is 4. So 4 root 2 all over 2, which is the same thing as 6 over 2 plus or minus 4 root 2 over 2. And then I can cancel those 2's. So it would end up to be 3 plus or minus 2 root 2. So those would be the x-intercepts. And there's two of them. So one is 3 plus 2 root 2, and the other is 3 minus 2 root 2. Now, if you were graphing those, it'd be nice to know about where that is. So the square root of 2 is like 1 point something or other. Times that by 2, it'd just be over 2. So 2 point, I don't know what the number would be, but 3 plus 2 and a bit would be 5 and something. So 1, 2, 3, 4, 5. It's going to be here somewhere. And then this one is 3 minus just quite, it's 2 and a little bit. So 3 minus 2 and a little bit is in between 0 and 1. So it'd be somewhere about there. You could figure out the exact number. Now, they didn't tell you to graph this one, but if we wanted to graph it, the value of x squared is positive. So if the value of x squared is positive, oh, and the other thing we know the y-intercept is 1. So if the y-intercept is 1 right there, then I can use that information to draw me a graph. So something like this, and then up like that. If I wanted to figure out what that vertex was, I could use that vertex formula, minus b over 2a, like we did on the other question. But they didn't ask it for on that question. Okay, hopefully that helps you with those two.